Hello viewers, in today's lecture we are going to study the integral of the type e raised to x f of x plus f prime of x. Clear? Now here this integral is equal to e raised to x times the function f of x plus c. So viewers, what does this mean? It means that if we have to integrate a function e raised to x times f of x plus f prime of x dx, then such integral is equal to e raised to x times f of x plus c. Let us take an example. Suppose we have an integral of this type. Say this is x square and we have 2x. Okay. Now see here, if we assume this function x square as f of x, then the derivative of f prime of x denotes the derivative of f, so this is 2x. Clear? So we can directly write the solution of this integral by using this formula. So we have e raised to x times f of x is x square plus c. Clear? Okay. Similarly, let us take one more example. Suppose we have to integrate e raised to x and say we have 10x plus sec square x. Clear? Now here also we see that if this is taken as f, then the derivative of f is, that is 10x is secant square x. So if fx is 10x, then its derivative is sec square x. So the integral of this function can be directly written by this formula, that is e raised to x times 10 of x plus c. C is the constant of integration. Clear? Similarly, let us take one more example. Suppose we have to integrate e raised to x and we have 1 over x minus here we have 1 over x square dx, then the integral of this function is e raised to x times 1 over x plus c. Why? Because if we take f of x as 1 over x, then the derivative of 1 over x is minus 1 over x square. So therefore this form is of this form. Clear? So this integral is of this form, therefore its solution is e raised to x times 1 over x plus c. Clear? Now let us take one more integral, that is e raised to x, and we have tan inverse of x plus 1 over 1 plus x square. Clear? Now viewers, we see that this integral is of this type. Clear? So if we compare and if we assume f of x as tan inverse of x, then we see that its derivative is f dash x is equal to 1 over 1 plus x square. So this integral satisfies the form of this integral, so this can be written as e raised to x times f of x is tan inverse of x plus c. Clear? So whereas these are some examples to illustrate how to find the integral of a function like this. Clear? Now let us see how we have calculated that integral of e raised to x f of x plus f prime of x is equal to e raised to x times f of x plus c. Clear? So let us derive this formula. Now let I is equal to this integral. Clear? Now this integral can be written as e raised to x. Let us multiply these two terms by e raised to x. So we have e raised to x fx dx plus e raised to x times f prime of x dx. Clear? Now here we have two integrals. Clear? And this is first integral, this is second integral. So let us say this integral is I1 and this integral is I2. Clear? Now let us solve the integral I2 by using integration by parts. Clear? So let I2 is e raised to x f prime of x dx. Clear? Okay. Now here we assume that this function e raised to x is the first function and this is second function. Clear? And let us apply integration by parts. So we have e raised to x integral of f prime of x dx minus we have integral the derivative of e raised to x, then we have integral f prime of x dx. Clear? Now the integral of the derivative of f is the function itself, so we have e raised to x f of x. Clear? Now minus this is integral and the derivative of e raised to x is e raised to x times and the integral of the derivative of f is the function itself, so we have e raised to x fx dx. Clear? So here we can write the constant of integration as plus c. Here also we can write the constant of integration as c. Clear? Okay. Now let us substitute this value of I2 in this equation. Clear? Here we have I. So I can be written as I1 or we can write this expression as e raised to x f of x minus this integral is nothing but I1. Clear? E raised to x fx dx. So this is I1. Now we substitute this value of I2 in equation 1. So what we will get? We have I1 and then plus the value of I2 is e raised to x fx minus I1 plus c. Now I1 and I1 get cancelled and we are left with e raised to x f of x plus c, and this is this formula. Clear? So whenever we have an integral of this type e raised to x and we have here the sum of two functions such that one function is the derivative of other function, that is here we have the function f and the other function is its derivative, then the integral of this function can directly be written as e raised to x times f plus c. Clear? Okay viewers, let us take some more problems based on this integral. Suppose we have to integrate x e raised to x divided by 1 plus x whole square. So let us call this integral as I. Now viewers, this integral can be written as x plus 1 minus 1 e raised to x divided by 1 plus x square. Clear? Here 1 and 1 get cancelled and we'll again get x e raised to x divided by 1 plus x whole square. Now let us break this function from this point. Clear? So we have integral, we have x plus 1 divided by 1 plus x square, and we have minus 1 over 1 plus x square, and here we have dx. Clear? Now here 1 plus x, and here we have 1 plus x square, so we can write here e raised to x. Clear? Now we can write this as this function as e raised to x. Now 1 plus x and 1 plus x, 1 power get cancelled, and we have 1 over 1 plus x and minus 1 over 1 plus x square. Clear? Now here we see that this integral is of this type. Clear? This type. How? If we take f of x as 1 over 1 plus x, then the derivative of f is minus 1 over 1 plus x square. So therefore the value of this integral is e raised to x times f of x plus c. Clear? And what is f of x? F of x is 1 over 1 plus x. Clear? Plus c. So this is the required integral of this function. Clear? Now let us take these two problems. So here we have e raised to x sin x plus cos x. Now the derivative of sin is cos. Clear? Sin x, the derivative of sin x is cos x. So if this is f, then this is f prime, and we have e raised to x times sin x plus c. So this is the required integral of this function. Similarly here we can write it as e raised to x, and if we multiply these two terms by sec x, we have sec x plus sec x tan x. Clear? Now if we assume that f is sec x, then the derivative of sec x is sec x tan x. So this integral is also of this form. Clear? This integral is also of this form. Now so this can be written as e raised to x times sec of x plus c. Clear? So we always remember that whenever we have an integral e raised to x and we have two terms here, one is the function and other is its derivative, then such an integral can directly be written as the product of the exponential function e raised to x times the function plus c. Clear? Now viewers, let us take some standard integrals, and here I have written three integrals. The first one is integral of square root of x square minus a square. Then we have the integral of square root of x square plus a square, and then we have the integral of square root of a square minus x square. So whereas these three integrals are very important, and we must remember these formulae to write the integral of functions similar to these integrals. And now I am not going to derive these integrals, but I am going to derive the integral third, and this integral is very useful when we'll find the area of bounded regions while dealing with application of integrals. Clear? So viewers, let us derive this integral. Let I is equal to integral of square root of a square minus a square x square dx. Now here we'll make use of the substitution method and we'll substitute x is equal to a sine theta. Then dx is equal to a cos theta d theta, and this term square root of a square minus x square becomes a square minus, for x we substitute a sine theta, so we have a square sine square theta, and then we can write it as a square 1 minus sine square theta. This can be written as a square cos square theta. Then we have a cos theta. Clear? So let us substitute these values here. So the value for square root of a square minus x square is a cos theta. Then we have for dx we have a cos theta d theta. Clear? Now this can be written as we can take a square outside this integral, then we have cos square theta d theta. Clear? Now here we'll make use of the identity for cos square theta, and we have a square, and we can write here 2, and here we can write 2 cos square theta d theta. Now this can be written as a square by 2 integral of 1 plus cos 2 theta divided by we'll have only 1 plus cos 2 theta. Clear? So for 2 cos square theta we have 1 plus cos 2 theta. This is a trigonometric identity, and now we have to evaluate this integral. So this can be written as a square by 2, and the first one is integral of d theta, the second one is integral of cos of 2 theta d theta. Clear? Now we can write it as a square by 2. The integral of d theta is theta, and the integral of cos 2 theta is plus half sine 2 theta plus c. Clear? Okay. Now we have to express this theta in terms of x. Now I can be written as we have a square by 2 plus theta. Now theta can be evaluated from this substitution. Here we can write x over a is equal to sine theta, and theta is sine inverse of x over a. So we can write here sine inverse of x over a plus, now we have half sine 2 theta. So this can be written as sine theta cos theta plus c. Clear? Because sine 2 theta is 2 sine theta cos theta, and 2 and 2 get, this 2 and this 2 get cancelled, and we are left with sine theta cos theta. Now this can further be written as a square by 2. We have sine inverse x over a plus, for sine theta we can write x over a, and for cos theta we can write square root of 1 minus sine square theta, which can be written as 1 minus sine theta is x over a, so we have x square over a square, so this can be written as 1 over a square root of a square minus x square. So if we substitute it here, we have 1 over a times a square minus x square, square root of a square minus x square plus c. Clear? So here we have a 1 over a. Clear? So now we can write it by simplifying this expression. We have I is equal to a square by 2 sine inverse x over a, and then we have here a square by 2 times x over a square, square root of a square minus x square plus the constant of integration as c. Clear? So I can be written as, here we have a square get cancelled, we have x over 2 times a square root of a square minus x square plus a square by 2 sine inverse x over a plus c. Clear? So yes, this is the required formula. Similarly, we can derive the first and second integral by using the substitution method. Clear? Now let us take some problems which are based on these three standard formulae. Now let us integrate this integral. Let us call this integral as I. Clear? So here we see that we have the integral of this form, that is square root of ax square plus bx plus c dx. Clear? Now what we will do here, we'll make the use of completion of squares. Clear? Or completing the square. So here what we will do, we have this this quadratic polynomial as 3 minus 2x minus x square. So this can be written as 3 minus x square plus 2x. Then we can write it as x plus 1 whole square minus 1. Clear? X square plus 2x can be written as x plus 1 whole square minus 1. So where's this can be written as x minus x plus 1 whole square, we have plus 1. So this can be written as 4 minus x plus 1 whole square. This is 2 square minus x plus 1 whole square. Clear? Now this integral I can be written as integral of the square root of 2 square minus x plus 1 whole square dx. Now let us put y is equal to x plus 1. So we have dy is equal to dx. Now this integral can be written as 2 square minus y square, square root of 2 square minus y square dy. Clear? Now here we see that this integral is of the form which we have just derived, that a square minus square root of a square minus x square dx. And the formula for this integral is x over 2, and we have square root of a square minus x square plus a square by 2 sine inverse x over a plus c. Clear? Now here the value of a is 2 because this is 2 square, and for x we have y. So we can write this integral as we can write it as y over 2 square root of 2 square minus y square plus this is 2 square by 2. We have a sine inverse of y over 2 plus c. Clear? Now if we substitute the value of y as x plus 1, we have x plus 1 over 2. Then we can have here 4 minus x plus 1 square plus we have 2 sine inverse x plus 1 over 2 plus c. Clear? Now this can be written as x plus 1 over 2 square root of we have 3 minus x square or 2x minus x square plus 2 times sine inverse of x plus 1 over 2 plus c. So this is the required integral of this function. Now let us solve this integral, and let us call this integral as I. Clear? Now we have to find the integral of square root of x square minus 8x plus 7. So again, viewers, what we will do, we have this quadratic polynomial, and we'll express it by completing the squares, and we can write it as x minus 4 square minus 16 plus 7. Clear? Now here we can write it as x minus 4 square, and we have minus 16 plus 7 as minus 9. This can be written as x minus 4 square minus 3 square. So therefore this integral I can be written as square root of x minus 4 square minus 3 square dx. Now let us put y is equal to x minus 4, so we have dy is equal to dx. Therefore this integral becomes square root of y square minus 3 square dx. Clear? Now here's as we have just seen that this integral is of the form square root of x square minus a square dx, and the integral of this function is x over 2 square root of x square minus a square minus a square by 2 log of x plus square root of x square minus a square plus c. Clear? Okay. Now we are applying this formula to this integral. We can write x over 2, means we have to write y over 2, then square root of y square minus 3 square, and this can be written as minus, this is 3 square over 2 minus of 3 square over 2 log we have y plus y square minus 3 square square root of y square minus 3 square plus c. Now again substituting the value of y as x minus 4, we have x minus 4 over 2, and if we solve x minus 4 square minus 3 square, we get the same quadratic polynomial x square minus 8x plus 7 minus, this is 9 by 2 log of x minus 4 plus square root of x square minus 8x plus 7. Clear? And plus c. So this is the required integral of this function. Clear? Now viewers, let us take these two types of integrals. The first one is if we have a function which is to be integrated like e raised to ax sine bx, and in second case we have e raised to ax cos bx, where a and b are two real numbers. Clear? So here I will make use of the method of parts, that is by integration by parts, and will make use of the formula of product of two functions as u integral of v minus integral the derivative of u integral of v and then dx. Clear? So here we'll make use of this formula to integrate these two functions. Clear? Now here as an example I have taken the value of a as 2 and b as 1. Clear? So we are going to integrate this type 1. Clear? So where's as we see that here we have the exponential function, here we have the trigonometrical function. Clear? So here we'll make use of the rule or the trick that isolate and the trigonometric function comes before the exponential function. So therefore this function is to be taken as first function. Clear? And this is to be taken as second function. And let us say this is u and this is v. Clear? So let us integrate. So we have I as u. First we have u, we have sine x, then we have the integral of e raised to 2x minus integral the derivative of sine x, then we have e raised to 2x dx. Clear? Now this can be written as sine x, we have e raised to 2x over 2 minus integral the derivative of sine is cos, and we have the integral of e raised to 2x as e raised to 2x over 2 dx. Clear? Okay, now we can write here this is half sine x e raised to 2x minus half integral of e raised to 2x times cos x dx. Now here we see an interesting thing, that now we have the integral, one more integral of this type. Clear? So initially we have an integral of this type, and when we applied the method of parts to this integral, we have obtained the integral of second type. Clear? Now if we again apply by parts rule to this integral, then we are again getting integral of this type. Clear? So let us now apply integration by parts to this integral. Clear? So now I am writing this integral separately here. I1 is integral of e raised to 2x times cos x dx. Clear? Now here's again let us take this as the second function, this is as the first function, and say this is u and this is v. Clear? So let us apply the parts rule to this integral. So we have we have cos x, then we have integral of e raised to 2x dx minus integral the derivative of cos x, then we have e raised to 2x dx, and here we have dx. Clear? Now this can be written as cos x times e raised to 2x divided by 2 minus the derivative of cos x is minus of sin x. Here we have e raised to 2x over 2 dx. Clear? Now this can be written as half cos x e raised to 2x minus this minus and this minus get plus. We have half, then we have e raised to 2x times sin x dx. Clear? Now here we see that again we have got an integral of this type. See? So from this step, and from this step we conclude that we cannot completely neutralize this integral. Clear? Or in other words, this integral or this integral cannot be exhausted completely. So what we have assumed, e raised to 2x sin x dx, it was I. So I was the integral of e raised to 2x sin x dx. So here we'll substitute for this integral as I. So we can have here half cos x e raised to 2x plus half of I. Clear? Why? Because we have supposed that I is equal to integral of e raised to 2x sin x. Now substitute this value of I1 in this step. Clear? So here's we get I is equal to half sine x e raised to 2x minus, we have half here, then we have the value of I1, and I1 is half cos x e raised to 2x plus half of I. Clear? Now this can be written as I is equal to half e raised to 2x sin x minus 1 by 4. We have e raised to 2x cos x minus 1 by 4 I. Now we take this minus 1 by 4 I to this side. So we have I plus I by 4 equal to half sin x minus 1 by 4 of cos x e raised to 2x. Clear? Now here's this can further be written as 5i by 4 is equal to, this is 4i plus I, 5i by 4, and if we take 4 as LCM here, we have 2 sin x minus cos x e raised to 2x. Clear? And if we further simplify it, we get I is equal to 1 over 5, 4 and 4 get cancelled, and we have I is equal to 1 by 5, 2 sin x minus cos x e raised to 2x and plus c as the constant of integration. Clear? So what was I? I was integral of e raised to 2x sin x dx. Clear? So viewers, the integral of e raised to 2x sin x is 1 over 5 times 2 sin x minus cos x e raised to 2x plus c. Clear?